Graphs of power functions, examples, and properties of the three different types. All right, so if they have integer power, and specifically integer powers that are positive. So if I've got my function f of x, and there's some number a, x raised to the n, and n is greater than 0, and an integer. Remember, integer means it's 2, 3. So it'd be something like, so examples of that would be 2x squared, 2x to the 4th, 2x cubed. I just left 2 because it's the same. You can have a different number than 2. Maybe I'll make a different number. 5x cubed, 5x to the 5th. Alright, which these really are polynomial types. And they follow the same pattern as any of my other polynomials. They're actually simpler cases. If it's the power function where it's the even and the power functions where it's odd. So if I have even positive integers, right? If you graph these first two functions, it's always going to be a parabola case. They're always going to come out. They're going to hit the origin, right? If I plug 0 in, I get 0 out. And then they're always going to open up like a parabola. Now, if I've got a higher degree, it tends to flatten out here at the 0, but it still has the same basic shape. And so those would be if my a is greater than 0. If a is less than 0, well, then it just flips it over and they're down here. That would be my f of x equals a raised to an even integer, right? N is even. Has that shape, right? Which would be these first two examples would have this shape here. Of course, they'd have the first shape, the blue shape, because they're positive a's. If they were negative, so if this one was a negative 2, it would have the red shape. All right, well, if they're even, what happens in the, sorry, those are where it's even. If they are odd, so these cases where you have an odd integer degree, or power, all right, so those cases, they're 5x cubed, 5x to the 5th. Right, so n is odd. The shape that comes out, if you graph either one of these two, so if you graph f of x, a to the x to the n, and my n is an odd integer, it has an s-like shape. Right, so it comes up like this, does hit the origin, 0, 0, and then has an s shape. So if you graphed f of x equals 5x cubed, that's the shape that would come out. All right, if you graph, suppose, negative 5x to the 4th, let's do a negative 5x to the 5th, all right, odd degree, it still has an S shape, but it's just on the other side. All right, and so if it's an odd degree, they have this S shape. So if this is an odd integer degree, it's a polynomial type, so the end behavior is shooting off to opposite infinities. The red case is when my a is negative. The blue case is when my a is positive. So it follows the same properties as the polynomials. They're just simpler because they're a single term polynomial. And so that's it. They're just either that simple S shape they cross at the origin, or they're the simple polynomial shape. All right, so those are if I have even and odd degrees where they're just integers. Integer meaning whole number positive values. All right, next we're going to look at the negative case, which is going to give me rationals, and that'll be in the next video.